This piece of technology is one of the best in terms of reducing injuries by monitoring load management over the course of a season, week, or day. NCAA Division I teams using this technology saw a 19% decrease in healthcare costs compared to an 8% increase in non-users. It has been implemented by sport organizations all around the world and is still growing to this day. From baseball pitchers to NBA stars, everybody is jumping. Yes, you heard me right, jumping. They are jumping on a piece of technology called force plates. And in this video, I want to show you how sports scientists are able to use this piece of technology to not only change how practices are ran, but increase performance in games. Imagine that you operate a team, but you have an issue that you're running into. Everybody is getting hurt with musculoskeletal injuries. How do you fix this? Maybe you think increasing their strength in the weight room will get them better, get big, get bulked. And maybe it's a, out of shape issue. Maybe your team is just out of shape, so you just run them after practice, constantly run them. Because you heard somewhere that fatigue causes injuries. So in order to not have injuries, you just don't have to have them get fatigued, right? Therefore, you run them back and forth and back and forth and back and forth after practice. In no way am I taking out my anger as a former player here. No, this is definitely an unbiased opinion about running after practice. But actually, in all seriousness, it is true that fatigue does have an increase in susceptibility of non-contact injuries. However, the way that the coach is looking at it is a little bit wrong. You see, adding unnecessary weight in the weight room or sprints after practice, just aimlessly adding things without any quantitative values, aren't going to get you anywhere, and if anything, will get your team even more fatigued in preparation for their upcoming game or upcoming season, therefore leading to the increase in chances of them getting injured. And the way to stop this is very simple. You just have your players jump on some force plates. It's really that simple. All you do is let your team do a couple counter movement jumps on a force plate, and you let the sports scientists figure out using the metrics from the force plates whether or not certain players, individual players, have neuromuscular fatigue.
Whoa. Okay, so like neuromuscular fatigue and whether or not a player is injured or not, like how...
Okay, I hear you, and first we got to figure out how these force plates actually work. How do these sports scientists use these force plates in order to create a model and create a database for player monitoring? One of the main things that force plates are looking at is this thing called ground reaction force. Every action has an equal and opposite reaction. This is Newton's third law. Essentially what it means is that every single time that you stand up or go against some sort of force, there's an equal and opposite amount of force that comes back to you. Even if you're standing still, you are putting force into the ground and that force is coming right back up at you. We can monitor this with the force plate. Specifically, when individuals are going through a counter movement jump, we can figure out metrics of not only how much force you're putting into the ground, but how much power you're generating and pushing up throughout the jump. Analyzing this could potentially give us a sign that somebody might have inadequate jumping mechanics and therefore cannot distribute their load efficiently enough and could lead to further injury besides the neuromuscular fatigue that we are going to be monitoring. Some important metrics that clinicians look at when testing a counter movement jump on the force plates are peak force, average force, and force asymmetries between limbs, as well as metrics like counter movement jump, net impulse, braking impulse, and propulsive impulse. These last few metrics are especially important to look at because of the concept of the stretch shortening cycle. The stretch shortening cycle is a way that muscles are able to enhance force production by utilizing stored elastic energy. Think of your explosive movements like a jump, sprint, or change of direction task. These explosive movements are utilizing the idea of stretch shortening. Take this rubber band for example. When stretched, it generates potential energy. This is the same thing that happens when your muscle lengthens. In a counter movement jump, the quadriceps and the calves lengthen as you're loading, going down into the downward phase of the jump. Next, there is a quick transition between the lengthening phase and the shortening phase in order to generate power. A quick transition is really important in order to transfer all of the potential energy that was created by the lengthening phase in order to put it into the power of the jump in the shortening phase. If your counter movement jump depth is really shallow, you aren't really lengthening your muscles to their full potential and therefore can't produce as much potential energy, and we'll see a decrease in overall force production. The idea of force plates have been around for a very long time. The first types of force plates were made in the 1950s, but were used almost exclusively for running analyses for 20-ish years. Top research labs like the University of Calgary, the University of Oregon, Penn State, and Nike all used force plates in understanding running mechanics, running efficiency, and shoe testing for shock absorption and injury prevention. By the mid-1970s to 1980s, a push for more kinetics-based analyses of different sports came to fruition as companies like AMTI were making more commercially available force plate systems. Sport research utilizing force plates were mostly used in terms of finding the biomechanically most optimal position that players should be in for creating certain movements, as well as load distributions of these movements. It was not until recently that more commercially friendly force plate systems were utilized and implemented in weight rooms for sports scientists to generate load monitoring and neuromuscular fatigue. This big push came in 2017 with Hawkins Dynamics being one of the first companies to develop a portable and Bluetooth connected force plate system that allowed many sport organizations around the world to utilize force platform technology. Now, how do they do it? Well, first, every player needs to jump on the force plate a few times for baseline testing. This is where they're going to start, and Z-scores based on not only the team average, but then eventually the individual player's average will be compared to against each other for the following days. The metric that most people, especially the players, are most interested in is jump height, which the force plate is able to easily calculate through exit velocity and the force due to gravity, right? After all the players have been tested on the force plate, whether it was on the day, the week, the month, however long the cycle is for the sports scientist, that sports scientist will then pull certain metrics that they deem are important for understanding the individual's physiological capabilities. We have already mentioned a lot of them, like peak force, average force, counter movement jump depth, propulsive impulse, rate of force development, etc., etc. If you want to understand what these measures mean in a deeper context and how potentially you would be able to utilize these for your team or athlete or anything like that, let me know down in the comments, and potentially I can make a video on how these sports scientists are able to create dashboards and understand these metrics and create dummy reports for, stakeholders or coaching staffs of that like. So if you're interested in that, let me know in the comments below and I might be able to make a video for that. These jumps that the players did will be comparative to the jumps that they did last week, yesterday, or 2 days ago. We can see that once a team gets back from a long away trip, their measures are down. They are, shot for their neuromuscular efficiency. And that's something that the sports scientist will tell the coaching staff in order to, create adjustments to the training load intensity of today's or maybe tomorrow's practice. Sports scientists have either a weekly or sometimes even a daily force plate schedule in order to track neuromuscular fatigue. David Howarth has a great lecture on this as he talks about his time monitoring neuromuscular status in elite Irish rugby players. He has worked for a few professional rugby organizations, the OKC Thunder, and now works at NYCFC, and knows his stuff. I will link the video in the description if you want to watch it, but I do want to point out one slide of his presentation that he has, which is looking at his weekly schedule for force plate testing in the season. He has his players jump on the force plate 2 times a week, on Mondays and Thursdays, with match days on Saturdays. This way he's able to see acute fatigue that is present on Mondays from the previous match day and communicates how fatigued the players are from the match to the coaching staff so they can accurately tweak the practice intensity of Tuesday and Wednesday. On Thursday, the players jump again, and this helps the coaching staff not only prepare for priming sessions on Friday leading up to the game on Saturday, but it also shows David and the coaching staff how explosive these players are, how ready to go they are, how neuromuscularly locked in they are and ready to go destroy people on Saturday. Again, David is really knowledgeable and the presentation is brilliant. I definitely recommend you check it out. Additionally, testing counter movement jumps frequently can be useful not only for sports scientists and the coaching staff, but other departments within the sports organization. For example, the power metrics that are seen in force plates can be used by the strength and conditioning staff. This can be a quantitative measure of neuromuscular efficiency in the weight room. Athletic trainers will also love this force plate data because if a player does get injured, there's enough baseline healthy data available for the athletic trainer to know where they are at in the return to play process. Having players jump on the force plates throughout the return to play protocol will understand where they are and how much they are increasing back to normal strength, normal efficiency, and normal neuromuscular efficiency. Using force plates in the return to play protocol can not only help the physician or the athletic trainer, but it could also help the athlete understand how fast they are from returning back to the field, going back to 100%. This is just one piece of technology that professional and collegiate teams are already using to try to keep their players on the field or court. This is just one of many of the pieces of technology that these sports scientists use on a daily basis in order to track load management and neuromuscular fatigue. So if you're interested in learning more about these pieces of technology that, professional organizations are using currently to this day, drop it down in the comments. Let me know. With that being said, I hope you had a great day. I don't know where I'm going with this. I hope you learned something. Thank you for watching.